Hello, you're welcome to my channel. Now in this video we want to look at average rate of change. Good. So suppose we have a function y written in terms of x, alright? So this is y equals to f of x, that is y is a function of x. Now the average rate of change as x changes from point x1 to x2 is given as y2 minus y1 divided by x2 minus x1. Or we can rewrite it as f of x2 minus f of x1 divided by x2 minus x1. So you look at each of these expressions, right? They are actually the same. So let me not use, I can actually use equality sign here. Reason is this, y2 is just a convention, right? Since y is the same thing as f of x, we can say y2 is the output when x2 is the input, right? So if x2 is the input in the function, then the f of x2 will be the output, which is the y2. Good. And again, when x1 is the input, f of x1 will give us y1, right? So these two things are just the same. So maybe we can be making use of this one, having in mind or keeping in mind that it is the same thing as this. Good. So I know you are familiar with that notation as the change in y over the change in x, all right? A lot of people call it rise over run. Well, those are inappropriate words, but it's okay. Good. Well, we can figure this out a little bit on a graph. So suppose we have a function f of x, okay, which is the y, and it's just a curve, okay. So let's give it some pair of axes. This is the x-axis, and then the curve is of this form, right? Good. And now we have from 2 points, so the average rate of change as x changes from point x1 to x2. So let's figure out some point. So let's say we pick this point, okay, and we call that the x1, okay, and then we pick another point here, x2, so we just dot it to show what we've got. Good. Now, we need to figure out what the output, what the y value will be, right? And that is just by putting x1 into the function, and when we put that into the function, the corresponding result will be called f of x1, all right? Or maybe you can call it y1. As I said earlier, the two of them are just the same, just a matter of convention. All right, when we plug in the second point, the output is going to be f of x2, right? Because the second point is just x2, or we can call it y2. Great. And then what we've got here is a line, all right? And we call that line a secant line. Just a straight line from this point to this point, so you can cross beyond. So this blue line here is called a secant line. It is a line that cuts through a curve or a circle, okay? It cuts through the more than 2 points, or at least 2 points on the curve. So if you call this point P and point Q, the line cuts through the curve at points P and Q. But that's not a concern. But that blue line is called a secant line. Very nice. Now, the average rate of change here is calculating, okay, another way of saying it is to say we calculate the slope of this secant line. How steep, okay, the steepness of that line. Is it very steep? Let's say if you have something like this horizontal line, there is no steepness, all right? It's not going up, it's not coming down. Maybe we have something like this. This one is okay, going up like this, right? Maybe we have another one that goes this way. So you just measure the slope of a line. Good. That is what we mean by the average rate of change from point x1 to x2. Okay, so we can bring in some examples for you, all right? And then we use these expressions, and then we find the average rate of change of some function from a single point to another point on the x-axis. Very simple. All right, let's get right into it. And here we've got a very nice example. We have if f of x equals to x squared, right, then we want to find the average rate of change as x changes from point 2 to point 5. Good. Now comparing that with this explanation, right, or maybe with this little statement, we have the average rate of change of that function as x changes from point x1 to x2 is given as this, or maybe that, right? Now we are given f of x to be x squared, Okay, so let me put down the function as solution. We start the solution. So we put down the function f of x to be x squared. I'm going to be making use of this convention. I really like this one, f of x. Okay, it shows you the independent variable, it shows you the input. Good. So we have f of x2. You know, this was changing from point x1 to point x2, right? So since it was changing from point x1 to point x2, we plug in each of those points into the function and we will evaluate it, all right? So from point 2 to point 5, so we can see there that x1 is 2 and x2 is just 5, right? Very nice. Good. And now let's see. We will need to find out what f of x1 is, because this requires that, all right? F of x1 will be, well, since x1 is 2, that means we're talking about f of 2, right? Good. And then the function tells us, when you have something in here, you raise that into power 2. So now that we have 2 in here, we will raise 2 to power 2, right? And that will just give us 4. That is 2 raised to power 2. And we just have 4. Good. And then next thing, we'll calculate f of x2, which is this is just going to be f of x2 is 5, right? So we just plug in 5 there. And then we need to check out what f of 5 is. F of x is x raised to power 2. So f of 5 will be 5 raised to power 2, right? Which is just 25. Good. And now that we've got that, we can now calculate the average rate of change. Let me just put it down here. Average rate of change. This thing is not a standard one, right? I'm just putting down average rate of change, all right? Maybe you don't have to use it just for the matter of brevity. Good. So we have that to be f of x2, which we've gotten that here to be 25, right? So I just put down there 25 minus f of x1 was 4. So we put down there 4 and then divided by 5 minus 2, right? x2 minus x1. That is 5 minus 2. Great. And then what we have here is 25 minus 4 is just 21. And then we divide everybody there by 5 minus 2 is just 3, right? Good. And then lastly, we enter with 7. So 7 here is the rate at which the curve is changing from point 2 to point 5.